Hello, so today we're gonna be looking at package number 2. And this package is going to be covering the branches. And today a new package got released. This package was the loops package. And you guys are going to find different content there and other problems. So some first announcements I want to make are that, let me see. So here we're going to create a test file here. And from the last video, I told you guys that you guys could declare variables like this, which is, and I was trying to declare like that, which wasn't right, because when you wanna run this file, it tells you there is an error, and indeed there is an error. So you can't do it like this. So this is called packing. We are gonna look at this later in the course, but you guys know that you guys can declare variables like this. So you save the file and run it, and then if you print X and Y, you guys will see that. Just give me a second. Yeah, you guys will see that you actually print these values. So this is how you declare it. If you wanna declare two variables with the same value, you can do it like this. So like that, and they both will have the same value. All right. And if you guys wanna check that, just run it, and you'll see that this is actually legal to do in Python. All right. Now let's go to the branches, and this is what we are gonna be looking today. Oh, some other announcements I wanna make is that on Wednesday, I'm gonna be solving the exercises for the first package and this package. So if you guys haven't done the exercises, they are the put in practice exercises. You guys can send them to me. But if you guys don't finish them, well, I'm not gonna make them all. I'm not gonna solve them all. I'm just gonna solve some of them. Yeah, the ones I think are more challenging, but yeah, I'm gonna spend some time on them. Yeah. So let's get started with the branches. First, we are talking about the syntax, right? And like last time, we said that syntax is important to understand, and one of the reasons is because you don't wanna have any syntax problem in your code. Those type of bugs are the most difficult to debug. So, and they are the easiest to solve. So if you have a syntax error, you will like a message will pop up. So if you print hello, and then world, this is a syntax error. So if you run it here, you'll see that it will tell you there is an error, and this is part of the syntax. So if you do it like that, this would also be a syntax error. Yeah. So just have in mind that you gotta understand the syntax before trying to actually write Python code. And some good examples are on syntax file. You will see it here. And these are some of the most common syntax errors you guys will face. And whenever you guys see a syntax error, just go to the whatever line they'll tell you to go. For example, here it was telling me to go to line 1, which is this line here. So yeah, and just fixing the syntax error would fix most of your code. So yeah, I just try to understand the syntax error before trying to write long lines of code or whatnot. Okay, I think that's gonna be clear for today. So just don't try to just try. It'll be easier as you keep trying and trying to solve and write code. It will be more natural. So one of the first topics we'll see today is the branches. So what's branching? Branching is an important concept here because as you guys can imagine by now, Python runs linearly. So it'll run this line first, print something, and then it'll run the second line after something else. But then if it always do the same job, it wouldn't be actually doing or solving for something, right? And we want to have this sense of do this in some cases and do this other thing in some other cases, right? So that's why you gotta use the branches or if-else statements. So if and then we can start by writing a Boolean value, right? So v equals to, and a Boolean value is just true or false. So yeah, it's just true, right? In this case, if it's true, or why don't we actually have an input? So we can do bool to convert whatever the input was, and then enter a Boolean value. And then we can say that the value can be either true or false. And then if the input was true, then you can do print input was true. Input was true. But if it was false, you can do else print input was false. And if we run this code, and then we put false, it'll wait, something happened.
Julio, what's Boolean value again? I didn't catch that.
Yeah, it's a Boolean value. So from the notes from Saturday or from package 1, you can, I'm explaining that a Boolean value, it's equals to either true or false. So that's a Boolean value, right? And this is basically a representation of a number, which can be 1 or 0. So if it's true, if a statement is true, we say that it's 1, and if a statement is false, we say it is 0, because it's like having a light bulb and the light bulb being off or on, right? So if you think about it, and if you read this here, it boils down to this sense of well, to be honest, we just keep it. Let's try keeping it like this: true or false, 1 or 0. And then by understanding this concept, we can understand whatever comes after, right? So let's say today is raining. And then if we ask the question, is today raining? And then if we say, if we go outside and we look that it's raining, it is a true statement. So today is indeed raining, right? So that's a Boolean value. It's just a logical value. And there are only 2, true or false. So yeah. Is that clear? Yeah?
Oh yeah, thanks.
Okay, yeah. So that's a Boolean value. And then if we look at the input, I don't know what was wrong here. Maybe, yeah, I don't know. Well, a Boolean value, since it can be either 1 or 0, we can also do it this way. And let's actually do it that way. So if it's 1 or 0, 1 for true, 0 for false. So if we run this and then we do 1, the input was true. Otherwise, if we do 0, the input was true too. Okay, let's forget about this. Let's just keep it with numbers. So let's keep it with numbers. And I know why this is happening. So it was happening because a string can be a Boolean value too. And if the string is empty, then that means that the string is false. And if the string has any value in it, the string is true. So if we try this, it should work. 0. And it was false. And if we put 1, it is true, right? Now it works because we are converting the string into an integer and then into a value and then into a Boolean value. So this indeed is true. We cannot convert the string directly to a Boolean value, but we can do this bridge here, which will do the job that we are trying to do. So yeah, this is how we work with branches. But in Python, we also have the sense of not only having two options, if or else, but we also have the if-else statement. So if we have if-else or if-el, if-el, elif, sorry, elif v, and now let's work with numbers because numbers at this point it's just easier to work with. So let's try to get a number in the range of negative infinitive to infinitive. And let's say that this number, if the number is greater than 0, then this number is positive. Positive. But if the number is equals to 0, less than 0, then we know that this number was negative, right? But if it wasn't greater than 0 or less than 0, then we know that the number is actually 0 because you cannot have a number that's if a number is not positive or negative, it's 0. Then input was 0. And if we try this, and if we put 1, input was positive, and it would do it again, input this time -9, input was negative, and if we put 0, then input was 0. So this is how it works, but just keep in mind that elif statements like this are going to just sorry. So if statements, you can have more than just one, right? And let's try to work with more of its statements right now. So we have another number, let's call it m, and let's also have an input of a numerical number, and let's see what number is bigger, if it's n bigger than m or m is bigger than n. So we first do a subtraction, that n minus m. So if this is positive, meaning this is greater than 0, then we have n being greater, is greater than m. Else, if we have this being less than 0, then m was greater. M is greater than n. Otherwise, m and n are equal. So if we do this, and let's put 2 and let's put 4, m is greater. And let's run it again. And if we put 4 and 2, this time n is greater. And if we give the same input, 4 and 4, m and n are equal. So yeah, this works. But what if instead of doing this, we wanna use the operation, the logical operation? So if n is greater than m, then n is greater than m. And if m is greater than n, then this is true, else these two are the same. So this could boil down to L if m is equals to n. So this means just equals, right? So these two values are equal. And then else, well, we cannot have a else statement here because we only know that there are only three cases, either n is greater or m is greater or m and n are equal. But you cannot have any other case, so we don't need the else statement, right? And if we run it, it should work. So 4 and 4, they are equal. 4 and 2, and is greater, and 2 and 4, m is greater. So right now you see that it works. So yeah. But what else can we do with this? In fact, there is actually only a subject that studies these Boolean values, and it's called Boolean Algebra. And I don't want to go too deep into Boolean Algebra because it will take a similar course to this, which could be even longer than this course is. But but the basic or the takeaway from this course is that I want to show you that to do Boolean algebra, you first need to understand the values of true and false. Once you understand those values, you know that it can be either 1 or 0 or true and false, right? And if it's true, and if you order with a false, they should be equals to a true. And if we print and we need to put this within parentheses, and it's true. And if you end this should be false. And that is true. Oh yeah, that is true because false equals to false is true, right? So it doesn't make sense, but like in Boolean algebra, it does make sense. So in general, we know that a Boolean value true and false will give a false, and a Boolean value of true or false will give a Boolean value of true. And you can keep ORing and another false and false and more falses, but you will always have a true value. So the basic idea here is that you need at least one true value here in order for this statement to be true. For this statement to be true, you need to have true statements only. So you need to have true and true and true and true. So the final result will be a true value. Yeah, is that clear? Okay. If there are no more questions, then we can just keep going. Yeah, and in Python code, you can do an if statement. If something, let's create a Boolean value and let's put it true. So if true, if B, then print something. But if you wanna do something right after the if statement, you can. So let's do something. Let's imagine a function that's called, let's do something. And it will do something. And you don't need an else statement right after if. Just keep in mind that, you don't need it, but it will sometimes be useful, and sometimes you will just have to do a short if statement. An if statement also has different structures, and you wanna keep it as this. First the if statement, then the elif statement, and then finally the else statement. You wanna keep these structures so you can have as many elif statements as you want, but you wanna keep this basic structure. You cannot have an else statement before an elif statement. What else do we have here? Oh, we have a string formatting. So if you guys had the time to look at formatting here, you can see that you got quite some material for you to review. But just to summarize that up, I will say that there are only two styles of formatting. You have a regular style, which is text dot, or the old style. And then you can have, for example, let's put a string here. And then let's just use text. Yeah, this is the old style. And if you print the string, 0, it should be printed as it is. We also have the new style, which is actually called string formatting. You do it like this, or you can also do it like this, which would have a similar result, but you wanna use this style because it just gives you more workability with your code, like you can see here. So yeah, and then in this format you can actually do the same thing here, like that. Yeah, and then you put a text or whatever you want to give them there. And then you print the string number 2 or number 1, and it works. So yeah, how is this useful? Well, I go more deeply on how this is useful here in this code, in these examples. But to summarize that up, I'll be short, and you won't find yourself using this a lot, but sometimes in some programs will require you to use a certain format and to print whatever your output is in a certain format so it looks nicer to the eyes. So let's say you have this text and more text here, and we have a string that is more like that. So let me just get rid of the first ones here. Yeah. So this looks okay, but you can have it in for example, center. So if you do, or to the right or to the left. For example, I want to do to the right, so I do plus, and I want to use only 20 spaces for it. I can do this, and then just put 20 here, and I think I gotta put the plus sign here. Nope. Then I can just have the 20 like that, right? Yeah. But I forgot. You use it like that. Yeah. So this is a somewhat more descriptive, or nicer to the eyes, as you can see here. And well, you won't only have 2 lines here. You can probably have multiple lines of code that are being outputted to the console, and you wanna just have an easy way to write it. And this could be a good option to do that, right? Yeah. Well, within this topic, we also can print these lines or this text, and these texts are called escape characters. The reason why they are called escape characters is because you use the escape, which is this character to print it. So if you put escape text or my string, and you put let's this time use the tab. My string is long. I don't know. So you can see that it prints a tab before printing the actual string, and it also prints a new line after before printing the second string, right? So this is a new line, and this is a tab, and a tab is just some white space, and it's typically long. It's typically long for spaces. So yeah, you also have a 0 here, which means nothing. So this is actually nothing, like printing nothing. So I want to say that this n is equals to that. And if we print this, we'll know that this is true. Let me just print it. Oh, it was false. Well, for in some other languages like C++, this is true, but this is just this represents a final line. You'll see that in other courses or learning C++ or Java, but yeah, it's just that. Okay. Besides the escape characters, we also have. Let's say you want to print my string within quotations, double quotation marks. So it's true that you can put this in single quotes here. So it will print the double quotes right after. But another way you can achieve that is by putting a here escape character right there and right there. So you'll see that, oh wait, let me just get rid of the new line character. Yeah. You will see that it's indeed printed by doing this, the escape character. And this is useful when trying to input characters that are not typically allowed to print, like that one, or even the escape character itself. Here it is. So you gotta put escape character before trying to print the escape character itself. Yeah, those are some useful functionalities of the escape character. If you keep scrolling down, you will find the data structure section, and this is part 1 or part 0. And I just go over some functionalities that Python provides to store different types of data. Let's say we have a list called L that has the following input: just a string, and it's gonna be a name. So we give it a name, and if you run this, and we want to print the list right after, print L. So let's say you have a program running, and if you want to stop it, you can put Control Z, or C as in I don't know, a word with C. I don't know, but it's C. So yeah, so you put Control C, and it should finish or terminate, and you see that here that it will give you like an error, but it's not actually an error. It's a signal that you send to terminate your program. Okay, so let's run it again, and let's put a colon here in the space so it won't be all different. And you put I'll put my name here, and then you can see that the list actually store a name. And if you wanna keep asking for names, or let's say this time you wanna have a number here, but remember you will have a string as a return value, so you wanna convert it into an integer, and you put the int function around the string. So I give it a name, my name, and then I give it a number, 21, and you have it here. And you see here that this is indeed a number because it does not have the how do you call this, the quotation marks. Any questions yet? No? Okay. So that means that we can keep I can keep showing you more examples. Well, you can also have more lists inside other lists. So I'm gonna have a name here, another name, and if I run this, I'm gonna just put I don't know, numbers and then another name. You'll see here that this is a list inside another list. So this is possible, and this is called nesting list. And you can nest as many lists as you want. You don't have like an actual number of lists. You can keep nesting, and this is useful for many cases. Like let's say you want to list a, well, this is not a list anymore. Let's just get rid of it. And let's say I want to list tuples here, and these are not tuples. That's a tuple. So you want to list tuples of coordinates. For example, 2, 1, that's a coordinate, or 3, 2, 3, 5, that's another coordinate. You can keep putting coordinates inside this list, and if we print this list, it should print this coordinate. So what are these data structures here? I've been calling them coordinates, but these are not coordinates. These are known as tuples, and tuples are just like lists. Let's say you have a 2, 3, 4, 5 tuple here, and you have another list that is 2, 3, 4, 5. These have the same functionality. The only difference is that tuples are not mutable. So if you ever want to change a value inside a tuple, you wouldn't be able to do so because tuples are not mutable objects. And I go more deeply talking about mutable objects in the newest the newest package that's got released today. And you will see that in that package, but I'm gonna talk about it next or this upcoming Wednesday. Yeah. What else do we have? Well, we also have sets. Sets are unordered collections of objects. And just like lists and tuples, you can also have sets inside any other set. So if you print the set here, you will be able to look at the, what was wrong here? Type error, unhashable, okay. You see, okay, it works. I have a set. No, so you cannot have sets inside sets, but you can have other data structures, right? No. Unhashable type. Yeah, you cannot have any other data structures. Only data of that is not like only unique data like numbers, maybe floats and all that, right? But for some reason, it's not letting you do sets inside sets or any other data structure. Yeah, tuples, like I said, are not different to list. They are just not mutable objects here. So yeah, this is a tuple. And you can also put tuples inside other tuples and list inside other tuples and list and so on. So if you try doing this, you should be able to achieve that. So you have it here. Now, you also have an operation. For example, you define a list to have 1, 2, 3, 4, 5, 6, or just these numbers. And then you ask for an input, if input, and you are going to convert it into a data structure, I mean a number, and you put number here. And this operand is called in, and it checks whether the given number or element forms part of this section here of the list. In this case, it can be a tuple or even a set. So it checks whether the number is contained within the list or whatever you want to call it, data structure. So print, and I give a message. Print given number is in the list. Else I print given number is not in the list. Is not in the list. So I put 1 and given number is in the list, and I put 10 and given number is not in the list. So if it works. And you can also use it with strings here. So instead of a number, we want to check whether an input of a letter belongs to this sequence of letters. Let's test it. So a letter can be, for example, if I put Q, the given, well, I gotta change number to letter here. So I put Q and the given letter is not gonna be in the list, or the given letter can be in the list if the input is in this sequence of letters. So think of a string as an special type of data structure, because it's just a sequence of characters, and single characters are also special in some programming languages. So yeah. Let's keep going with this. And let's talk about indexing. So let's say you have a list that has the following sequence of numbers. And then you only want to have, you want to print L at index. This is going to be an index. And then you put input. And since the index only works with integers, you want to transform that input into an integer. And you can do index from 0 to this 1, 2, 3, 4, 9. So from 0 to 8. Right? Okay. And then if we try to run this from 0 to 8, well, let me just put here a colon and space, so it looks cleaner. I want to have index 0, and the element at index 0 is just 1, right? Because that's the first element. So index 0 is first element, index 1 is second element, index 8 is the 9th element, or the 9th element. So if we put 8 here, it should be 9. So the last one. And then you can also give negative numbers. See, so if you put -1, you get the last number. If you put -2, you get the previous last number, and so on. So that's how it works. And indexing only works for order sequences. So list will work. A tuple would also work. So you have these elements here. And also a string will work, because a string is just an order object of characters. So you have A, B, C, D, E, F, G. Right? And it wouldn't work with the with a set. Why it wouldn't work? Why do you think it wouldn't work with a set? Well, one of the reasons is because a set is not ordered. So so a set is only a collection of objects. So if you try to do indexing for a set, you will have an error, and it'll tell you that this object is not subscribable, but it's actually not indexable. So yeah, that's one of the reasons. So it works like I said with a string. So if you put the element 0, it's the first element, which is A, and you can keep going with this, right? What else can we index? We can index tuples, and we haven't seen dictionaries yet, but you can index dictionaries too, I think, yeah. And what else can we index, or how can we work with this? Because this seems like a good functionality, right? Well, we also have this, which is called slicing, which is which kind of looks like indexing, but it's not indexing. It's called slicing, and you put a colon here. So you put input. Also, you want to transform it into an integer, and you put it here, index and 2. So you give it a number first. Let's say we are indexing a list, or sliding a list. So you put L, the first number, which is N, going to the second number, which is M. So yeah, this is going from index N to index M, and it's not inclusive. So M wouldn't be in the substring or sublist or whatever you are sliding for. So you put it here. Let's go from 0 to 4, and you would only have these digits here. So it only gets 0, 1, 2, 3, and it doesn't include the object 4. So yeah, it works. What else can we do with sliding? Sliding also provides this functionality, which is called stepping. So you can do a list from N to M in a steps of S, which can be any number. So if you want to use this, and this is starting to look really messy. So let's just copy and paste it here to F to like this. And then you can just put steps equals to this. And it should also be an integer. In steps of okay, let's see. Let's go from 0 to 7 in a steps of 2. Oh, wait, never mind. Let me just comment this one out. And let's do it again from 0 to 7 in a steps of 2. And you have it here. Wait, no, I forgot to include it here. So you gotta include it here as steps. Yeah, let's try again. 0 to 7 in the steps of 2. You have it here that it'll have 0, 2, 4, and then 6, and it won't get to 7 because 6 plus 2 is 8, and 8 doesn't form or is not part of the sliding number. Yeah. You can also reverse a string, for example, or a list. Since they are ordered, you can do this. I might just print it right after, and I'm not gonna ask for any input because that takes too long. So I'm gonna go from -1 to negative in a steps of -1, so going backwards. And you see here that the list gets inverted. Yeah. How do you copy a list, for example? If you want to make an exact copy of the list, you can just do this. By doing this, it will make an exact copy of the list. Yeah, so this list here that gets returned and the list here are two different lists, but they just happen to contain the same objects or elements. And now we can get into built-in methods, and that should be the final topic of this package. So let's look at some functions that are no methods. So some functions that aren't methods are the function print is not a method. The function input is not a method. The function int is not a method. The function string is not a method. The function dict is not a method. And there are other functions like length is not a method. And there are more and more and more and more functions that are not methods, and you'll see them as you go through this. But these are not methods because, well, first I want to show you guys what are methods, and I'm not going to talk about much about methods right now because it'll get more confusing, but it will be clearer when we get there to objects, to understanding objects and classes. So let's create first a list, and let's just put these numbers here. And let's say you want to add another number to this list. So you can just do print the list here, and you'll see that this list just contains those numbers that I just put. But if I want to add another number, I can call the method append. And you see here that in order for me to call the append method, I gotta put a dot here and then write the method here, which is called append. And this is a method because these are kind of like functions that only works for certain objects, like a list. The only list can or have the append method or the append function here. So yeah, this is how a method looks. And if you want to append, for example, the number 5 here, and then print the list after, you'll see that this list actually adds the value here. We have more methods like clear that will clear the list and just get rid of all the values there. So you see here. And then we also have methods for strings. So let's create a string called, and let's just put my name in there. And then just print the string, the uppercase. And this is also a method because you can see here that it calls the dot here and then the method right after. And you see here that the upper method will return a new string with all the characters being uppercase characters. So this is very useful. And to be honest, many functions and methods that you will see here through the course, these are gonna be, you don't have to know them all, but you kind of have to get familiarized with these methods and strings. And you can certainly go to the official Python library, which is given here, to see just how many functions there are. Let's just take a quick look at it. These are built-in functions. So you have these functions to work with. You can see the print function here. You see the float here, the iter. Well, there are functions that you haven't heard of yet, but just keep in mind that you have them there. So we also have another keyword which can just delete elements from the list. So if you want to delete an element from L, you can do pop and then give a index to pop. Let's say we want to the element at index 1, and it won't be there. And then if you want to print but if you want to also delete another element by not calling pop, you can do this, and it will delete the second element because the first element was deleted here. So if you do this, you will have only 3 and 4 left. You can keep calling delete on L0, and more elements will just be deleted. Now we just have 1. And that's basically it. Why do we use list instead of tuples? Well, like I said, tuples are not mutable objects, and what mutability means is the ability to change objects. So this is a list, and this list cannot be, or it can be modified because lists are mutables, and a tuple cannot be modified. So for example, if we have a tuple of 3, 2, 4, 5, and if we try to delete tuple and the element at index 0, we will have an error here. And this is because tuples, like I said, they are not mutable objects. So you cannot delete anything from them, or you cannot change them. So yeah, that's one of the reasons you will prefer to use list. But just to keep that in mind, that doesn't mean that tuples are not useful at all, because there are some cases where you will need to use tuples instead of a list, because they are safe to use when you're working with objects that you don't want to modify. Let's say you have a tuple of list, and you have a list there, and let's just create another list here, which is 2, 3, 4, or let's just put 20, 30, and 40. And you want to delete, well, you print it first. So let's print this, print the list or the tuple. And you see here that this is a tuple of 2 lists, right? But then you want to delete elements of this list. So how do you do this? First, you wanna get the element that you need. So we wanna use the first list. And then you use the second list, the indexing of the first list within the tuple. And let's say we want to delete number 1. So you put the element 0, the index 0, and you delete it. Is this legal? And I want you guys to think about it within the time that I print the tuple. And if we give it a try, something happened here. Gosh, tuple. Oh, okay. Yeah, I don't know. 0. If we do this, print this. Okay, yeah. So how would you delete a value here? 0. Well, in order for you to delete such value, you gotta understand that this value here, there is a list, and you can certainly call pop on a list and then delete the first element. And if we print t, that should do the job. And I don't think you can call delete on it because I just tried right now and it didn't let me. Let's see. Oh yeah, so it lets you. I don't know why it wasn't letting me just a moment ago. So you can call delete on it. Like this, it deleted the element. Why? Because we are not changing the tuple itself. We are changing the values within the tuple. So that's possible to do. Any questions yet? I might just wait for a little moment so that you guys can formulate a question on the chat. No? Okay. So yeah, today we cover the syntax, the conditional branching, the if, else, and else if. We cover the strings formatting. We cover the first data structures, data structuring and the indexing, and also the sliding thing. We also saw some functions and methods. Can you put an if statement in a list? Yes, you can put an if statement in a list. So let's create a list of, well, I see what you're trying to say. And yeah, these are called one-liners, but we'll get into that later in the course because actually we're gonna review this in week number 3 because one-liners are a special type of coding. So you can put a lot of functionality in a simple line of code, and I'll show you how. So you can put if-else statements in one line. For example, true if input is, let's just have two inputs. 0. Wait. So you can have 0 and 1. These are the only inputs. So true if input is equals to 1, else is false. If you print L, then it will run this. And if I put 0, that's false. And if I put 1, that's false. Okay, let me see. Oh yeah, because 1 in this case is a number. So we wanna transform it into in a string. If we put 1, this is true. And if we put 0, this is false. So this is how you put an if statement into a one line. And you can also put a else statement into a list, but this is called list comprehension. I might just show you how, but I'm not expecting you guys to work with this right now. So let's create a program that takes all the absolute values of the numbers given. So first we wanna have numbers for, and we wanna have a number, an int, n, for n in input, and we only want to have a list of numbers. So numbers, and then you can just do a split, which is a method of a string, and you want to have an integer of the number if the integer of that number is greater than 0, else you want to have the negative integer of that number. And if we do this, and if I put it like this, 2, -3, 4, 5, 6, -100, -20, I get a list of only positive values, or just the absolute value of them. So this is how it works. You can you can put an if statement inside a list, and these are called comprehension lists. So yeah, good question. But we are gonna be looking more deeply into this for week number 3. Any more questions? No? Okay. So like I was saying here, looking at the schedule, we're doing good. The only thing I'm worrying about is that you guys are not turning in the work or the exercises yet. So I mean, it's fine. I know you guys are probably doing something. Um, yeah, just try to work on them. If you guys have any questions, just send me a message. I'll try to help you guys as much as possible. I'll give you sources. I'll give you more examples. If you guys do the problems, or if you guys think the problems are too hard, just let me know. I'll try to lower the level. But just keep in mind that this is it's an accelerated course, which means that the pace of this course is gonna be fast. So yeah, just have that in mind. And so far, I'm still working on some things here for week number 3. But here are the one-liners that I was talking about, and I'm getting the week number 2 package done. So yeah, I just have that in mind. Um, any more questions yet? Let's see. What else can? Oh yeah, this video will be, or this mini video will be online. Um, will be online tonight. Hopefully, I'm gonna upload it tonight, and it will be there for you guys to watch it and for other people to watch it. So if you guys have any questions, just watch the video again or send me an email. And if you guys know a person from the course that is missing, and you guys invited them, you guys should tell them to come to the meeting. I'm just kidding. Like, they don't have to come, but they gotta do the assignments and all that, read the notes. I feel that the notes are actually helpful, but if the notes aren't helping, then you guys should let me know too. Well, let's take a quick look at the folder number 2, and let's get started with this folder before me letting you guys go. Let me just close this, and let me just close that too. Let me make another file here and call it test 02.py. And right here. Okay, let's open this up. So like I told you guys, this package should be online right now. It got some examples too, and then put in practice problems here. These are the exercises for you to look at and work with them. And let's just take a quick look. We are gonna be looking at dictionaries here. So what's a dictionary? A dictionary is basically mapping. So we have keys, and the explanation goes here, but we have, let's say I want to create a dictionary called D, and we give them keys of numbers, which are going to be number 1 to represent A, number 2 to represent B, number 3 to represent C. So you have a dictionary declare like this. You can declare like this and work with it. So the keys are always going to be the first values here, and the second values are always going to be the values. So this is a value and this is a key, and they are denoted by the colon, and they are separated by commas like this. And if you print a dictionary, it should be here. So this is a dictionary. And you guys see that it works. And why are dictionaries useful? Or how are these dictionaries useful? Well, these are other type of data structure. So this is called mapping data structure. And you guys use the same brackets for indexing, but instead of using the index here, you use the keys. So key number 1 will give you A, and you see that key 1 gives you A, key 2 gives you B, and so on. And you can actually have more values here. For example, I put key number or key F, and I give it a list of numbers. You have a list of numbers, and I look for the key for what value is associated with key F, and if I print it, oh well, I need to put the column here. I forgot. So yeah, and if you put it here, you see that it's a list, and since that is a list, you can also index the list, and for example, ask for the value at index 2, it should be 3. So you can see the output is 3. So yeah, that works. What else do we have? We have more explanation on dictionaries. We have methods for dictionaries. So you have, if you want to print all the keys in a dictionary, you can do keys. And this will give you a list of all the keys. And if you just want the values, you do values. And it'll give you a list of all the values like this. And if you want both of them, you will get you will have to use the items the items method, and you'll get a list of tuples of keys as the first position and the value as the second position. Yeah. And I'll talk about mutability in this text, but I want you guys to read it before me explaining it. And we also get into loops. So what are loops? In computer science or programming, you often want to do a task repeatedly many times. So for example, if you wanna program or a group of tasks to be executed for, let's say, 2 times. So 4 times in random, in range of 2, I'm gonna print hello world. And you see here that these tasks get executed 2 times. So you can do more things with it. So and we're going to start asking for inputs. If input, if int, let's work with numbers because I like numbers. So numbers in the range of -infinitive to infinitive. So if the input is greater than 100 or 0, that's positive. Print it's positive. And else or elif the same. Oh well, at this point we gotta store the input somewhere, so we can use the same input to work with this. So let's just store in a variable name called x. Only if x is less than 0, well, we know that it's a negative number, right? It is it's a negative number. Else, then x print it is 0. It's 0. Okay, and let's run this for n times. So how do we specify how many times? Well, we convert it into an integer, whatever the input we are asking for. So a number, and this should be string number, and we can just expect the answer to be right. So let's run it for 30 times. 1, 2, 0, 4, 0, 0, 0. And this will work for as many times as you want. This has an error because I put Q there. But yeah. So this is basically a loop. But this variable name here called times is actually useful for us sometimes. So if you print the time, or let's just call it time. If you print time, it should be the number we are currently in. Let's just do it for 3 times. The first number is 0 because we always start from 0 in Python. And then let's use 2, let's use 3, let's use 1. And after 3 execution, it stops. But what if we have a list or element in list, or just let's create a list here, and let's put random numbers there, 3 and then 1, and we just print the element here, the element. It'll give you each element there, you see? And then it also works with Topples and strings. So strings will give you each character. Let's put it in a string, and it'll give you each character. As you can see there, it's giving you all the characters that the string has. And you can also work with the set, and it'll give you the values there. And since a set only has individual values there, if you put more 3s in there, it'll give you only 1, because a set only has unique values in them. We also have while loops. So while something, here is an expression, and this expression can be either, it has to be a Boolean value. So it can be either true or false. And this while loop will run as long as the expression is true. So if you have a value, for example, I equals to 0, and if you want to say that you want this expression to run as long as as long as I is less than 3, and you print hello world here, and hello world, and then you add 1 value to I. So the value of I will change. Otherwise, this will cast an always running loop. So you see here that this only runs for 3 times, because after the third execution, the value of I is 3, which is not, and 3 is not less than 3. So yeah. What if you don't put this in there? Well, it will run for whatever, and it keeps running. It's still running. But you don't want to have that, because this will cause some errors, and you can seriously damage your computer system too. So just don't do it. Don't do an infinite loop. Well, you can actually have an infinite loop, and Python will sometimes stop the infinite loop and tell you that this is an infinite loop and it never stopped. So as a secure system, it kind of stops for you, or stops the while loop for you. But you don't want to have a while loop that's an always running program. So because that can cause some errors, and that's not good for your computer. So what I like to do with while loops is that I use while loops whenever I know there is the program that is potentially going to be running kind of for a long time, or that I don't know the certainty of the program yet. And I always like to do while true. And you guys think that this is wrong because this program will always run forever, and that's also true. The I like doing this and having a break statement here. So if, and let's still work with I. So I equals to 0. So if I is greater than or equals to 3, then we break. And then we do the I plus equals 1 here. And this will do the same thing. And the reason I like doing this is because sometimes you will kind of have to do some things previous to exiting the while loop. So let's say we want to print by before exiting the while loop, and we have a by message here. Or let's say I want to change the state of I back to 0. So when I print it here, it's not 3, it's 0. Oh, I mean I, sorry. And yeah, it's 0. Or you want to do some other things, or sometimes the statement gets too long that writing it here becomes a little bit more difficult to do. So you can have ors and ands, or true and false, and it can get longer and longer and longer. And having that in a while loop here gets confusing sometimes. Or sometimes you want to exit after the program does something like this. Oh, let's just get rid of this for it to work. So what will happen here is that this program will only run 2 times. And I mean, yeah, wait. No, never mind. But if I have this here, like this, will run 4 times. Well, yeah, never mind. So yeah, but sometimes the position of the breaker statement is important. Like this will run more than the given times or the expected times. But sometimes you want to be doing that for certain reasons, and some other times you will have other conditions for the statement to break. For example, J gets printed, I mean, gets a value of 2 here. So if the value of J, I don't know, it's greater than the value of I, this will run only 1 time, because after the first execution, we know that the value of I will be greater than the value. I mean, the value of J will be greater than the value of I. So that's one reason. But you can have multiple break statements within the same while loop. So if you do these, for example, this will not do anything. This while loop you will enter the while loop and then break. And then if you do false here, or if the statement is false, you don't even enter the while loop, because initially the statement is false. So you see, you don't print the well. Yeah. Any questions yet? I'm gonna wait for a little while. You have nesting values here, and I can explain how to work with nesting values, and I'll give you some examples there. Yeah, and then you guys will learn how to handle exceptions, but we'll talk about that later, like Wednesday. And then non and pass. Okay, let me talk talk about non and past for a little today, and then we'll just say bye after. So if true, we pass, else pass. So what do you think this program does? Print, I don't know, let's print something. That's it. So if you run it, it won't do anything. But it will run. It won't give you any problems too. But if you get rid of the pass and you leave these statements like this without anything in there, it'll give you some problems. It'll tell you that you need to have something below the if statement or below the else statement. But sometimes when you are structuring your code and kind of thinking on how to work with some of the tasks that they ask you to do, and you don't know yet, so you use the pass keyword, which will eventually make your program not complain. And this is just for you to use it as a placeholder, so you can make the structure first and then work with whatever you want to do after. So yeah, that's how you use the pass statement. The non, it's just a value. So if you give J the value of none and then you print J, it will give you none. But none is not equals to 0. None is not false. None is not an empty string. None is just a data type that you can use for different motives or as a holder too of a value. So J is meant to have a number, but you don't, or it's meant to have a value, but you don't know what value yet. So you put none to give it a value and for it to work. Maybe later in the code you'll have J to be equals to a string. So that's that. And we're pretty much done with today. We actually took quite some time. Okay, yeah. Let's just forget about this. Okay. Any questions? I'm gonna give you guys like 1 minute to think of any other questions. And let me just wrap this up. No questions. Okay. Yeah, okay. If you guys don't have any questions, then I'm gonna stop recording now.